me, John Park, and... Hello and welcome to John Park's workshop. I'm John Park. This is my workshop. Here we are, and I want to thank everyone for stopping by today. It is getting hot here in Southern California, so all bets are off. Who knows what could happen? I haven't brewed any iced tea or iced coffee, so that's a problem. I do have some water, some delicious cold ice water, and I kind of expect some cameras to start malfunctioning due to the heat. We'll see. Maybe it's finally time to build that water-cooled camera radiator sensor project that I've been threatening to do. Hey, all right. So I want to first of all say hello to people who are stopping by in the chat over in YouTube. Hello, Vanessa, Kitty, and hello, Charles Burniford. It snowed in Connecticut, huh? Wow, Vanessa, Kitty, that is the opposite of the weather we're having here. And hello over in the Discord chat. If you don't know, if you're viewing this over on Twitch or Facebook or Periscope, the chat is mostly happening on Discord and YouTube. And I see Jekyll Ryan, Andy Calloway, Wolf220, Dan Mitchell, O'Kyron. Oh, okay, you're on. I finally learned how to pronounce your handle there, Steve. C. Grover, hello, everyone. So let's get this thing started. I've got a bunch of cool stuff I want to talk about today, particularly the project of the week, which has to do with a sort of teletype machine that I'm very excited about diving into. But first thing we'll do is mention our jobs board. Did you know? We have a jobs board. If you head on over to jobs.adafruit.com, you can take a look at open positions and you can post your info if you're looking to hire someone for some freelance work, contract work, full-time work, on-site, off-site, remote, anything you can imagine. You can do it. It's all free. And you can also post your resume and info if you're looking for exposure so that someone might take a look and decide to offer you some work. So please head on over to jobs.adafruit.com to find out more. And let's see, what else have we got? The next thing I wanted to mention is what? We have a special show and tell happening a little later today. That's the show and tell that I'm going to run right here out of my workshop. You know what? I may even try to move it inside into the studio because it's cooler in there. We'll see. The show is going to be at 2:30 Pacific time and 5:30 Eastern time. We'll do about a half hour. You can head to our Discord, so the Adafruit Discord, to find out more. There'll be a link there for the StreamYard URL that you'll use to go in there. You just need your browser. There's nothing special you need to go in. And you can show off a project that you've got, something you're working on, something you've finished, something you're thinking about doing, some cool parts that you're thinking of working with. Who knows what? We're interested in seeing it because show and tell is fun. So please come on by in a little bit after this show to check out the show and tell. Wolf220 said, my head looks like it's shifted to the side. What do you mean? There's so many of me. And what else have we got? Let's see. Oh, in case you're wondering, yeah, when I keep talking to Discord, there it is. That's the Discord chat, including the very helpful gauge that we have up there, the meter display of my audio level. Sounds like the audio level is working pretty well. Do I dare push it just a little bit? I don't want it to peak out, but it looks like that's good to me at least. All right, what else have we got? So I'm not doing a coupon code right now during these bizarre times, but I will mention that many items that you can purchase on Adafruit normally are now available on DigiKey. So if you go to the Adafruit site and you look around in the store, you'll very often see a new button, a red button that says Buy on DigiKey. In fact, I'll show you one of those right now because I want to talk about my product pick of the week. And my product pick of the week this week is the Featherwing Tripler. So, excuse me, if you're familiar with the Feather can take feather wings that usually mount on top of or below it using a combination of male and female socketed headers. The Doubler, which we have, and the Tripler, and there's others, but I'm going to talk about the Tripler today, allows you to put them side by side, and it also gives you a nice amount of prototyping area. So Essentially, the pins are replicated 3 times, and so anything you plug into one is connected to the pins on the other 2. So it's a nice way to put 2 or 3 feathers side by side. Here's a doubler that I have. I used that for this project from last week, which is that SD card ADA logger feather wing with the RTC battery powered real-time clock on it and a regular feather. Those are just plugged into this feather wing doubler. But you can see there we've got some nice prototyping area, so you can lay down some little circuits that might help you do stuff. Tripler is kind of nice because it allows you to put a wing, a feather, and then leave that prototyping area open in case you want to not even populate it with the headers, but instead put some buttons and LEDs and things like that there. So that's my product pick of the week. And the very cool thing is that if you head on over to the DigiKey site, or if you go to Adafruit and find the product, you'll see there's a buy on DigiKey link, and then you can go on there and check out. They are shipping orders out right now. We'll be shipping out later when things return to something resembling normalcy. But right now, that is my product pick of the week, and you can pick it up at DigiKey. So thank you, DigiKey. Let's see. What else? So at this point in the show, lately, I've been doing a little gear report, but actually the gear report this week is embedded in the project. So I'll tease it right now. I'll show it off to you. This is my gear of the week. It is a Teletype machine designed as a communications device for the deaf and hard of hearing. These were used in the 1960s through still to today. It's one of the only reliable ways to use text communications on analog phone systems. So for people who don't have a digital connection, an IP type of telephone connection, those are still in use. Mostly it's been superseded by more modern devices, texting on phones and computers. But these are really interesting. They were developed after sort of the Teletype teleprinter by an inventor who was deaf himself, who had an interest in amateur radio, and he did some experiments with using these to communicate by text over amateur radio, and then eventually he and a couple of other guys, the Wikipedia article is great for this, as some other articles I looked at. I don't have their names, but go look them up. I believe they developed the acoustically coupled modem for their purposes. So you can see here there's a speaker and a microphone built into the top of it, and these are designed for the more traditional round handset. I've got a kind of square one here, but the speaker would be set over that microphone port, and the microphone be set over the speaker port, and you kind of jam it into this little cradle, this little rubber cradle, and now we're able to send and receive audio signals. And I'll talk a little bit about how that system works now, and then more when we get into the project. But essentially this uses the Baudot 5-bit encoding that was used initially for Teletype. And it encodes up to 32 characters as zeros and ones, a frequency shifted key, so low and high tones. And there was a clever discovery, or invention, which was, since we can't really get past much past the alphabet with only 32 characters, there was a shift key, which actually is sort of a little preamble that changes the whole system into accepting the same set of 5-bit codes, but representing them as numbers and symbols. It's called the figures key, also shift or figures. So it's kind of like layers. Particularly, by the way, interesting if you're in the sort of mechanical keyboard scene. These look sort of like 60% keyboards, or some of them even look like 40% keyboards, where the numbers are just shifts on top of the top row of letters. And it uses that same concept of layers. So there's sort of macro functionality or alternate functionality depending on which keys you press. So we'll look at some of the actual audio coming from that and how it works when we get to the project. But I just want to kind of show that off as the project of the week. I picked it up, by the way, really inexpensively at a Goodwill auction. In the end, it cost me $5 plus shipping, which wasn't bad. Hey, Dave Estells, welcome over on the YouTube chat. Dave Estelle says I need an old school round handset for that. In fact, the only round handsets I have are lineman's handsets, which you might remember from some of my earlier projects. So that one fits on really nicely, and it's got the rotary dial back there, which is pretty slick. So that one will work if we want to get very round and old school and proper with it. But let's see. So I think, yeah, the other thing I'll say is that you may find these around. There were, I believe, in one article I read, there were at least 50,000 of them put out in early days of the adoption of these standards. And I'm imagining hundreds of thousands of them are out there. One other interesting thing about it is that the system was used a couple of different ways. One could be end to end. So you have one of these machines on each side. You make a phone call. You each connect up your modem, your telephone handset to the modem to couple them. And then each person takes turns typing. It's half duplex, so you'll type on top of each other if you're not careful. That's one way to use it. Another was using a service in the middle, and I forget what this was called. It has a name. Someone will probably remind me in the chat. A service where a operator would be on a teletype machine like this, or a TDD machine like this, and then would speak to the other party. The other party would speak to the operator, and the operator would type. So you could have this sort of halfway point between them. And a couple other interesting facts about this. I found that these ran on either battery power with a pack of nickel cadmium batteries, which were all entirely dead, using this little, it was 6 volts of nickel cadmiums, and it fit up in here, or with a 9 volt DC wall wart adapter. That one was center negative and a weird post size, so I left it alone, but I essentially found the battery circuit was dead, so I grafted into the same DC circuit with a 2.1 millimeter barrel plug, the same kind that is more common, and it's center positive. So that I can plug a 9 volt battery into. It won't last too long, I'm guessing, but it does work, or just a 9 volt wall wart. And the other super cool thing is, I had a guess when I first saw this auction come up. I said, you know what, I bet you that's some really nice Cherry MX key switches in there, because that was the most common way to build any kind of a keyboard like this. And sure enough, it's full of Cherry MX blacks. So really, really nice key switches in there, and double shot keycaps for all you mechanical keyboard nerds. Relay operator service. I'm looking in the Discord chat, and that is, Mr. Certainly said that that's what that service was called, the relay operator service. Another thing, by the way, that I'll mention is there are, again, I'm not an expert on the history of this, and there's probably a lot of overlap with amateur radio, teletype, and these TDD devices, but there are a lot of early shortcuts that were used on these, such as GA meant go ahead. So that was kind of like saying over on a radio. So you were telling the other person, you're done typing, it's your turn. And there were a few other shortcuts like that, BRB for be right back. Common things that you see now in texting were used here to make communications quicker and easier. Oh yeah, and in fact, RO stood for relay operator. So I think if someone had a question for the relay operator, they would use RO to stand for that person. All right, so that is my gear report, and it'll feather into the project of the week. But before we do that, let's dive into the Make Code Minute. Okay, let's get set up here with my Chrome session. Here we go. And in fact, let's do a little demo of this project before I show you how it works. So for the Make Code Minute today, what I wanted to do was build a Circuit Playground Express project that would allow me to record a sequence of button presses and then have it played back. So what I have is a switch on the Circuit Playground Express that puts me into record mode or play mode. So I'll go into record mode, and that clears a sort of record buffer. And now I'm just going to press the buttons in an order. So red, red, blue, blue, blue. Now I'll switch over to playback mode and I'll press the A and B buttons and it'll play red, red, blue, blue, blue. And now if I switch back and do, let's say, red, blue, blue, red, switch, and play, it'll play it back. And there's actually no limit. This could be one press. This could be 100 presses. I don't think that we'll ever run out of memory on it. So it's not looking for a particular length, just however many I press until I switch the switch over. So let's take a look at how this works. If we look in my MakeCode session, I have in this onStart block, I have a little variable I've created that's called the record state. And you didn't hear them, but I also have this playing back some notes, or I did at one point, maybe, I don't know, some tones when I press them. And I'm turning on the little LED, the red LED in the corner, so I know that I'm in record mode. And then I also turn on these two to blue and red so I know which sides mean what when I'm in record mode. This function here is what I'm using to light things up. So I'm calling that either the left side or the right side. I think I had one for left and right. And then this is what happens when I move the switch. When I go to the switch with the left, I set the record state to false. I blank all of the pixels, and I turn off the red LED. When I head over to the right, I'm going to turn on that LED. I'm going to create a new array. So I essentially rebuild this array every time. And it's an empty array, so it doesn't have any data in it, and it doesn't have any particular length. I set a variable called pattern length to 0, so that's how long that array is at the moment, and I set this record state to true. Now what happens is when I press either the A button or the B button, these do essentially the same thing. If I have if I'm in the record state, and I press the A button, we'll call that light half of 0 or 1, so which side gets lit up. And then I'm adding an item to this array. So this pattern list array gets a value set at whichever index number we're on. We start at the first one, or 0. And we set that to a 0, which stands for the left half, and I'm using a 1 to stand for the right half. And then we increase the pattern length by 1. Same thing when I go and press the B button, except it's pressing it for the other side. So then when I want to play this back, I'll press the A and B buttons together using this button A, B click, and then it just reads through each item in that array, calling that light half. So the same way I'm lighting them when I press it, it reuses that same function, but this time it's just marching its way through this array. And so this is a way that you can create a pattern recorder that could be used for a lot of different things. In this case, I'm using it for lights. And it'll work right inside of the MakeCode simulator if you don't have hardware, or if you want, you can use this on the Circuit Playground Express. And that is your MakeCode Minute. All right, excuse my drinking sounds. I know that I'm going to expire if I don't get some liquid in me here. All right, so let's see. That was the MakeCode Minute. Why don't we move on to talking about the MakeCode Arcade game pick of the week. And I'm again going to bring up a Chrome browser. Let me hide that title there. So my arcade game pick of the week this week is called Adventures of Sam and Nate. This is from Jacob C. And he says, here's a new short game prototype I've been working on. He says, I don't think I'm going to explain much about how it works. You should try to figure it out. You will definitely want to try the B button, or you can use the Enter, or I think the E key on the keyboard in the simulator. So we'll pop this open, and the first thing I noticed when I saw this, I realized that this is among kind of one of my favorite game types, sort of simple game mechanic, which is two characters that one player has control over in turns. So what I mean by this is if I use the D-pad to move, I'm moving one character around. And we can see I'm opening up an obstacle here by standing on this B button, but I can't move fast enough to get past that gate. So that means I'm going to need to switch to the other character and sort of leapfrog the controls back and forth. So if I press E, that switches to the other character. So every time you press E on the keyboard or the B button on the console, we switch control. So now I have this second character. I'm going to jump up here, and I find another switch, my assumption is that's going to keep that little switch is going to keep the wall down. So now I can switch back to the first character, and sure enough, the wall stays down because someone's standing on the weighted switch. And then finally, we'll get to the exit, which is this yellow dot. I'll switch to this character, and hooray, we've made it past that level. And it's got some scoring here based on the number of presses, so I probably pressed the button more times than needed. Oh, looks like my character here is stuck on level 2, can't go anywhere, so let's switch to the other. Aha! And now we have some control, so I'm going to switch back. And I really like this, especially when you start to have the characters in different enough parts of the level that the camera, when it shifts over, doesn't reveal everything at once. So this is a new mechanic that's introduced in this level, which is you can stand on top of that wall and use it as a lift. So I'm going to switch back to this first character, move off this weighted switch, and my second character pops up. And now we can both escape. So really cool. I love this kind of gameplay. Let's take a look briefly at some of the game blocks. This is built in blocks. And I wanted to look at how the character switching works. So you'll see here there's a block that says on B button pressed, it calls a function called setActivePlayer, and it calls it with an argument of essentially which character isn't being used currently, and that's done with this sort of modulo remainder of active player index plus 1 divided by 2. So that's a way to switch back and forth between player 0 and player 1, I think. And that function that it calls here is this, setActivePlayer, which player ID, so that's the one that's been called. And then we will move Nate with buttons VX and Sam with buttons VX velocity on X and velocity on Y to 0. So it means they both stop essentially when we switch characters. They stop moving. We set the active player index to that player ID that was called. And then we use either the first character, Nate, index 0, is set to the active player sprite, or the second character. And then we resume control. The buttons will now move whichever character is active at an 80% velocity on X, and they don't go up and down with the controls. That's only for jumping. And check this one out. The camera follows sprite, active player sprite. So that's what shifts the camera to essentially be centered on the player. So I thought that was a really exciting prototype of something that could turn into some really great gameplay. And so that is my MakeCode arcade game pick of the week. It is Adventures of Sam and Nate by Jacob C. How cool is that, huh? Given some of these games that we've been checking out lately, I think this is a really great time to be making and playing the MakeCode arcade games. So if you've ever been thinking about getting into designing games, the MakeCode arcade sort of ecosystem and interface and that IDE for it are also nicely self-contained. You don't have to install anything. You don't have to go hook a bunch of things up, download stuff. It's just all right in the browser. So I encourage you to check it out if you've ever been interested in checking out how to make games, or even just looking at how games are built. Let's see. Someone in the chat, Mr. Certainly, said he thought I said Adventures of Salmon 8. That'd be an interesting fish-based adventure game. Someone should write that. All right. Let's see. What have we got next? I think it's time to get into our project. So I talked a bit about the TTY machine. Let's head over there, and I'm going to show you a couple little demos of it in action. And so what I'll do, I'll go ahead and power it up. Like I said, I can do it from battery, or I can do it from a cord. I'll do it from the cord, so we don't run out of battery. And let me turn this around, and I'll zoom the camera in so you can see that. And hopefully you'll also be able to hear it pretty well. So I'll turn it on. And it has this little vacuum fluorescent display. It says AT&T TDD 2700. That's the model number of this. And you might not see it too well, but there's actually a couple of status lights here. And you can see as I'm talking, there's a red LED that's blinking to show that it's receiving some tones, receiving some audio. This isn't, my speaking voice isn't in a frequency range that it's going to turn into letters, and I'm not speaking in the timing it's expected, so you're not going to see anything magically show up unless you had a really amazing whistler come by and try it. But that's the microphone port there. This is sort of a little coupler that depresses when the handset is on there, and it gives you a really nice coupling acoustic interface between the microphone and the speaker on the handset. This one's just a speaker in there. You can kind of see the speaker cone if you wiggle it just right in the light. And what I'll do is I'll just type some letters, and you'll hear these. And in fact, I'll put my mic near here so you hear them. Oops, typo. So it's got a backspace key here. You have, like I mentioned, some shift keys. So there's an apostrophe. And we can use the numbers. And something that really interesting that I noticed is, check this out. When I press an A, listen to the length of this. Ba-da-doo, ba-da-doo. When I type a 1, it's going to be twice as long. And the next time I type that 1, it's going to be back to normal length. Next time I type the A, it's going to be twice as long. Next time it's going to be normal length. And that's that letters or figures preamble. It might not be the right word for it, but essentially there's a code that says we're switching between alphabet and the numbers and symbols. And so that's interesting. It's not a separate key that you press once and then proceed. It actually includes it the first time you switch between modes. It also, according to the specification, every 72 characters, it will just reiterate the one that you're in. So if I type 72 of the letter A, that 72nd one is going to be twice as long because it's going to play that little preamble. So that is it in action. Now check this out. And sorry, I hope you could hear me. I realized I was far from my mic there during that whole explanation because I was holding it down here. And I'll show you something also that's interesting here is I can go to the voice memo recorder on my phone, and I'll record something. Let's turn this on and off just to clear it. And stop. So I typed in hello, and I'll delete that. And now, if you look at the screen here, when I play this back, we might get lucky and it'll pick it up well. Close. It typed a T instead of a E. Let's try it again. Yeah, it worked that time. So I might need to be louder or closer to it, but you can see it's fairly forgiving. It has, I believe, an automatic gain compensation in it, so it's able to adjust the incoming audio because there could be some variance in what's coming over the phone line. And so when I did that, at first I was like, okay, that's exciting to see that it's going to allow me to just record a WAV file or whatever file format it is on the phone and hear it back. So that means I probably could play a WAV file back from a clue, or I might even be able to generate tones in essentially real time from a wavetable and play them back. So let's take a look, before we attempt that, let's take a look at the audio I captured when I just put a microphone up to that and recorded it. So here you can see on top is a letter A coming from the Teletype. The one on the bottom is what I've been generating from the clue as I try to hone in on some precise, sample rates and timings and stuff. But this image here on top, let me zoom this up a bit. Let's go like so. So what you're seeing here are two frequencies. There's a 1400 hertz frequency, that's the lower sounding tone, and an 1800 hertz frequency, the higher sounding tone. The 1400 actually represents a binary 1, and the 1800 represents a binary 0. For whatever reason, that's the ones they picked, even though it's kind of flipped in my mind. So that means this one right here is playing an 1800 hertz tone for 20 milliseconds, which is what the specification calls for. Then it's playing so that's a binary 1, followed by a binary 0, and that, I believe, is the start bit. So a new letter will be preceded always with those two, a 1 and a 0. And then I believe the 5 bits of the letter begin here. So now we have, in this case, 11000 is what that next set of spacings means, and that's the letter A. And then there's a stop bit of a 1, that's again low, 1400 hertz tone, followed by either 1.5 times or longer than the usual transmission rate carrier tone, which is the 1400 again. So what you're seeing there is an A. And I don't have an image right now of lots of other letters, but they all end up looking a whole lot like this, with just changes in that middle section of the 5 bits. And so what you see at the bottom is my attempts right now to replicate this on the clue. One thing you'll see is that it's a very nice pure sine wave that's coming out of the TDD machine, so it has very few harmonics. The very bright yellow is the fundamental frequency, and it's also the most powerful frequency recorded in my software that I'm recording the audio with. I don't have as pure of a tone coming out of the clue, so I have other harmonics, which may or may not cause problems, but I think right now I'm able to get a pure enough tone for it to recognize if I'm talking about a 1400 or an 1800, and I think I've got the timings pretty good. So this right now seems like it's close, if not perfect, for what we're trying to do. Now, in figuring out what to actually send, I can do it just by studying the waveforms and writing them down. I also found the specification in a couple places, including Wikipedia, and this is the specification from the International Telephony Union or something like that. And this gives me the Baudot or 5-bit codes for different letters, as well as in another standard here to the right. And so again, we can see A is listed as, let's see, can I zoom in on you? Yeah, let's zoom in. So you'll see the letter A here on this chart is listed as 00011. And I was scratching my head about this because this is actually the exact opposite of what I was seeing until my good friend and often partner in crime, Todd Kurt, said, oh, I bet it's least significant bit. So it's essentially reversing the order that it sends it in. So A is 00011. It's just transmitted as 11000. So that took me a while to, I wasn't going to get that. I was like, why is this absolutely mirrored and wrong? And Todd gave a good explanation for that. So thank you, Todd. So that chart there is what I'm working from, and I've started to write some code with the help of Sedacious and Jepler. They helped me come up with some code that does wavetable generation. So let's pop open, I'm going to plug in my clue, and I'm going to pop open this code in Moo so you can see what this is looking like so far. It's not elegant right now. There's a lot that once I really have my head around things, oh, now it's making a lot of noise. Let's tell it to stop. And let's load in code.py. Yes, thank you. Stop. Okay. So let me show you Moo. There's Moo. Okay, so first of all, Audio Core. This has replaced, Audio Core and Audio PWM-IO have replaced some of the Audio I/O functions from previous versions of CircuitPython. So that was something new that tripped me up. And so Kattni is updating some example code in our guides. And again, thanks to Sedacious and Jepler for hipping me to that. This here is, let's see if I can make this a little bigger, big enough for you to see. Yeah, that should be good. Hold on one second. So here, this little function called make sine wave. It has 3 arguments. What frequency sine wave are you trying to make? The sample rate, so how many points to put on this sort of table that will look like a sine wave in the end, but it's actually discrete points. And then the amplitude, how high are the peaks from the midpoint. This then generates this wavetable that I can reuse over and over again. And so if you just use it on its own by default, it'll make a 440 hertz tone, but I'm actually going to create some higher tones, which is right here. If you look at, I have a variable called bit1, and that is using the make sine wave function with a 1400 hertz tone. 26,000 is my sample rate, and this was mostly me just playing around with, at lower sample rates, it just, the harmonics were way too overpowering versus the fundamental, because it's essentially a sawtooth type of wave or a triangle type of wave. It had a lot of harmonics. So we want to get closer to more sample points where we get a smoother sound, and the fundamental is more prevalent. And then this is the amplitude, and this originally was 2 to the 15th. I've knocked it down a little bit. It seems to distort less over this little speaker. And by the way, I'm using my favorite little Stemma breakout speaker and amplifier here. It's a little Class D amp with a 8 ohm, 1 watt speaker on it. And that's just plugged into the clue there with alligator clips. If you remember, I used that for my dual tone multifunction tone dialer as well. It works really well for some of this phone stuff. Then I'm building bit 0, which is this 1800 hertz tone. The DAC on board is being instantiated with this PWM-IO, and it's on board A2. This is a bit of a gotcha. This took Jepler asking a really good question when we didn't think things were working, and it's because the clue has a silkscreen on it that's the same as the microbit, I believe, which it calls this first connector here number 0, but that is actually connected to a I think, digital 0 maybe, and it's connected to analog 2. So to use analog 2, not analog 0, took some doing. So I'll put that in the guide that I write up. And then here's the slightly messy part. Right now I've got some little functions that are, I'm calling this one a Bordeaux bit, and I give it a pitch, which is by default the 1400 hertz, and a duration, which I'm actually going a little longer than the 20 milliseconds. I found I needed to tune this timing, and at the moment this 24 milliseconds seems to be working well. And then the DAC, the digital audio analog converter, will play this pitch, and it loops that sine wave for however long this sleep duration was, which was this 0.024. Now I'm creating a function for a thing that I'm calling the Bordeaux start. This is the start bit, and this is playing a 1400 hertz for even a little bit longer, and then a 1800 hertz, so that sends that low high, or bit 1, bit 0. This is, I'm not using this at the moment, but this is the letters code. So if we're switching between figures and letters, we're going to send 5 ones to go to letters. I forget what sends the figures code, but it's in that table. And then here are the 3 letters I'm playing around with right now. So here's an A. And if we remember that chart, it was 00011, but flipped for least significant bit order, so 11000, that should send an A. Here's a B, here's a C. So I'm just preparing these right now. I'll do this hopefully with some dictionary or list of lists or something later. And then the stop bit, I am playing around with this stuff too. So it's the same as the carrier, but the DAC turning on and off versus just playing for a longer time seems to maybe be causing some different behavior. And then I have wrapped these up into, okay, a send A. What happens when I want to send an A? Right now, I'm sending the start bit, the A, and that carrier. I'm actually not sending the stop bit at the moment. This is some of the experimentation I'm doing. And then I stop the DAC. So in my testing right now, I have, let's not be so ambitious, and we'll comment out everything but send A. So you'll hear right now, that's what my send A sounds like. Let's unplug that, and I'll bring it over to the bench cam here. And let's see how it does, attempting to just send an A. So I can clear that of what was on there. Let's get some USB power for my clue. And now it's just going to send every half second an A. And there we go. That's working pretty well at the moment. As I move it around, it's getting funny reads, but let's try to get it consistent. So I'll type some other things so we can see it moving again. I had it pretty consistent there. I think it also has to do with, like I said, the volume and how close I'm holding it, and also with these speakers you get different effects based on sort of the soundboard it's on. So that one's working okay, not great, not perfect, but let's take a look at, so in investigating what's going wrong with like very minute timings or the sample rates or stuff, I've run across some letters that seem to be very consistent, and I think they are just more forgiving. So where I'm having errors, the letter I'm trying to type is okay with those errors. So if we look at, I think the letter B, let's see, stop the beeping. Let's just change this to a B. And to send a B, it's sending 10011. So let's save this. Okay, and let me go plug this in, and we'll see if we're getting consistent Bs. So the nice thing is I have a great get-out-of-jail-free card that I think may be pretty foolproof, which is playing back WAV files. And these are small enough that I should be able to dice everything up into recording waves off of here. So even if there's slight inconsistencies with how I could play back tones from the clue, I should be able to play waves, crossing fingers, with great fidelity. So that's another option here. But I'm being a little hard-headed right now and hoping that I can do it with these wave tables. So. Okay, so there's the letter B. Oh, look, it got a S there for a second. All right, so now I'm getting very consistent letter B. So that might be a clue about what letter is going wrong sometimes, and is probably like the second to last one or something. If it's a 0, can cause problems, but it's picking it up if it's just a series of ones, because that's what I have in that carrier tone at the end. So you can see if I type some other stuff or delete, it'll then just start picking those up again. So that's where I'm at with this, and last thing I'll show you, just because it's fun to see, especially when it works, is a couple of letters going. And then besides just exploring this, one of my ideas is to create a phrase playback. So pre-build like a sentence or a phrase on the clue, and use the UI and the buttons to be able to have it just type out a long phrase, which I think would be kind of cool. So let's change the what's happening here to just be send A. It'll wait a half a second, and send a B. Let's try that. Okay. Partly adjusting the amplitude was just because I was going nuts from listening to that really loud sound, so I'm not sure how much it wants that. But. Oh, it's getting the, yeah, like I was saying, it's getting the B's consistently, the A's not so much. That could be just a clue of how offset I am from what I want. Oh, now it's, you know, there were a few in a row. Yeah, I'm holding it just right, I think. Was. All right. So I'm pretty excited about that. One other thing is that on the other side of things, there's a printer port here, a 10-pin Centronics for a dot matrix printer, which was a way of preserving conversations. I think they would spool out in real time with a printer attached. And later models had a small, probably a thermal printer or some other tiny printer built into them. So that might be a way to explore going in both directions. And we may get to the point where we've got the horsepower necessary on a future board, maybe even on this one, but Lady Ada was saying she's just not sure right now if we could do a fast Fourier transform and frequency analysis so that we could listen using the clue. So it would work in both directions, reading and writing. So let's pop back over to the Discord for a moment before we wrap it up. Where is my Discord? Where'd you go? There it is. Oh, Charles Burniford has a really nice suggestion. If you can find an old rotary headset that might make the input clearer, yeah, send it through a phone handset. That's a really interesting idea. And I think probably this one here will be the one to use, which is my lineman's butt set or lineman handset, because it has just alligator clips built onto the end for, I might be able to hook those up directly to the board. We'll see. I haven't thought too much about it, but that could be really fun to send it over that. And I also have, I've got this one, which I don't know where the other half of it went. I had two of these. This is a handset that was used for, I think, on a Navy ship. And it's there's no, it's just like a direct, you pick it up and you're going to talk to somewhere on the other end. It just has a couple of alligator clips on there to connect to. And I think it might be a push to talk. So fun stuff. I'm glad you're into it with me, because who doesn't love telecommunications gear and freaking and such things? Let's see. Charles Burnford says 1 start bit, 2 stop bits, 5 bits. All right, I'm gonna have discussions with you people later about what we think is the optimal way of looking at how the start bits, stop bits, and all that works, so we can get this thing working well. All right. Well, thank you all so much again. Let's see. Before we go, I will mention again that we have the show and tell happening in just about 45 minutes. So if you want to swing by at 2:30 Pacific or 5:30 Eastern Time, if you head to the Adafruit Discord, and you can find that by going to adafru.it, adafru.it/Discord. That'll give you the automatic invite link you need to go to Discord. That's where I'll post the StreamYard link for the show and tell, and I'll also be putting a blog post up momentarily and also right at the start of the show. And so then you can come by and show us something and spend a few minutes discussing a project that you're excited about. So we look forward to seeing you. That's it. That's it for the show. Thank you again for stopping by. For Adafruit Industries, I'm John Park. This has been John Park's Workshop, and I will see you next time, and I'll see you real soon.